Welcome to the DIY Honda Garage channel. The DTC C1C02-14 indicates a problem related to the brake pedal stroke sensor in the 2017 to 2022 Honda CRV. This diagnostic trouble code specifically highlights issues with the signal circuit of the brake pedal stroke sensor, which can occur due to it being shorted to ground or being open. The brake pedal stroke sensor is a vital component because it helps in detecting the position of the brake pedal, thereby ensuring safe movement of the vehicle. Typically located near the brake pedal assembly, its role is crucial as it communicates with the vehicle's electronic control unit, ECU, to determine the extent of brake engagement. This communication is essential for activating the electric brake booster, which assists in achieving optimal braking performance. Not addressing this DTC may lead to compromised braking efficiency or failure, posing serious safety risks. The DTC C1C02-14 is associated with the brake pedal stroke sensor, which provides crucial information about the brake pedal's positioning to the acceleration control module and the electric brake booster. This sensor operates using a signal circuit that can encounter faults, such as being shorted to ground or open, leading to improper brake signal transmission. When the signal is interrupted or changed unexpectedly, the brake system may function erratically. The error frame provides a snapshot of the sensor's status and identifies if the issue is intermittent or persistent. Since the brake pedal stroke sensor is positioned close to the brake pedal, any physical damage or worn wiring can similarly cause erroneous readings. It is important to thoroughly diagnose and rectify any issues with this sensor to ensure vehicle safety and performance. The leading causes for a DTC C1C02-14 are shorted or open circuits in the brake pedal stroke sensor signal circuit. A shorted circuit occurs when electrical contact unintentionally connects two pathways, leading to abnormal readings or errors in signal transmission. Conversely, an open circuit happens when a break in the wire prevents electrical flow, giving rise to false readings or complete lack of communication. Damaged wiring, often due to wear and tear or exposure to moisture, can also result in circuit issues. Thoroughly inspecting the wiring harness and connections will help determine if physical damage is the root cause. Each of these potential causes must be methodically ruled out during troubleshooting to ensure a comprehensive diagnosis. Symptoms associated with DTC C1C02-14 may vary but often include noticeable braking performance issues, such as delayed response or erratic braking actions, which could put the driver at risk. Additionally, the vehicle's dashboard may display warning lights related to the braking system, prompting immediate attention. The electric brake booster, which is dependent on inputs from the brake pedal stroke sensor, may also exhibit symptoms of malfunction, potentially resulting in substitute braking techniques being employed by the driver, such as increased pedal force. Further, any signs of abnormal behavior from either the brake pedal or associated systems should be carefully noted. Recognizing these symptoms early can play a crucial role in managing vehicle safety and performance. The initial step in troubleshooting DTC C1C02-14 involves utilizing the Honda Diagnostic System, HDS, to check for any diagnostic trouble codes. Start by turning the vehicle to the on mode, which powers the necessary systems for the check. It is critical not to open or close the driver's door during this phase, as this could disrupt the vehicle's state and lead to misleading diagnostic results. Clear any existing DTCs from the system using the HDS. And after clearing, turn the vehicle to the off lock mode. Wait for a minimum of 5 seconds to allow the systems to reset. Subsequently, switch the vehicle back to the on mode and recheck for any DTCs with the HDS to see if C1C02-14 reappears. If it does, further troubleshooting is warranted. Step 2 of the troubleshooting process concerns checking for open wires in the system. Begin by ensuring the vehicle is in the off-lock mode and open the driver's door, as this keeps the vehicle's systems in a diagnostic state. After 3 minutes of waiting to stabilize, remove the 12-volt battery to ensure that there's no electrical supply during inspection. You'll then proceed to disconnect both the electric brake booster 26P connector and the brake pedal stroke sensor 4P connector. This step allows for a safe environment to check for continuity between specific test points. Test point 1 is located at the electric brake booster 26P connector number 11, and test point 2 is found at the brake pedal stroke sensor 4P connector female terminals number 1. Verifying the continuity here effectively helps determine if an open wire exists along this circuit. Continuing with the troubleshooting process, Step 3 focuses on verifying the continuity of the power test signal ground, PTS GND line. First, ensure that the vehicle is still in the off-lock mode and that both the electric brake booster and the brake pedal stroke sensor connectors remain disconnected. In this step, measure continuity between test point 1 at the electric brake booster 26P connector number 5 and test point 2 at the brake pedal stroke sensor 4P connector, female terminals number 3. If continuity exists, it indicates that this PTS GND line is intact. If not, an open wire condition exists that requires repairing. Failure to address wiring issues could lead to reoccurrence of the DTC. Thus, proper checks must be ensured. In Step 4 of the troubleshooting procedure, further checks will focus on the continuity of the Power Test Signal 1, PTS1 line. Again, ensure that the vehicle is in the off-lock mode and both connectors are disconnected as in previous steps. Measure continuity between test point 1 at the electric brake booster 26P connector number 22 and test point 2 at the brake pedal stroke sensor 4P connector, female terminals number 2. This procedure allows technicians to detect any potential break in the wiring along the PTS1 line, understanding that an open wire could significantly disrupt the functionality of the brake pedal stroke sensor. If continuity does not exist, remedial repairs on the wiring must be conducted to rectify any faults before proceeding to the next step. Step 5 involves checking for any shorted wires along the PTS1 line to ground, keeping the vehicle in the off-lock mode with both the electric brake booster and brake pedal stroke sensor connectors disconnected. You will now test for continuity between test point 1 at the electric brake booster 26P connector number 22 and test point 2 connected to the vehicle's body ground. If continuity exists, this indicates a short to ground in the wiring, necessitating immediate repair. A short to ground can compromise the wiring's insulation, thereby affecting signal quality and functionality. Should a short not be detected, the troubleshooting can proceed to analyze further connections for other issues. The sixth and final troubleshooting step focuses on checking for shorts between the PTS1 line and the PTS ground line. By maintaining the vehicle in off-lock mode and ensuring the aforementioned connectors are still disconnected, the technician will check for continuity between test point 1 at the electric brake booster 26P connector number 22 and test point 2 at the electric brake booster connector number 5. If continuity is confirmed, a short circuit likely exists in the wiring that requires rectifying. If no continuity is detected, the assessment must shift to examining the electric brake booster 26P connector for any loose terminals, poor connections, or corrosion. as these can also disrupt correct operational behavior. In some scenarios, checking for authorized service information might offer insights. And if all is good, but the DTC persists, replacing the electric brake booster may be necessary. In the final phase of troubleshooting, it becomes essential to conduct a final repair verification to ensure that the troubles addressed have successfully rectified the issue. Begin by rechecking for any DTCs in the Honda Diagnostic System, HDS, to ensure that the C1C02-14 code has been cleared from memory. If no codes return, this indicates that the repair actions taken have been effective. Next, it is crucial to verify the vehicle's braking performance under normal driving conditions to confirm stability and reliability. This trial allows the technician to ensure that the repaired components are behaving as expected and that the braking system functions responsively without issues. Final repairs are not complete until the diagnostics confirm the system's operational integrity and full compliance with safety standards. To prevent recurrence of DTC C1C02-14, regular preventive maintenance on the braking systems is strongly advised. This includes routine checks of the brake pedal stroke sensor and its wiring harness, ensuring integrity is maintained. Any signs of fraying, wear, or corrosion in the wiring should be addressed immediately, as damaged wiring can lead to intermittent failures or shorts. Moreover, making it a habit to inspect all electrical connections and terminals associated with the braking system can prevent loose connections, which often lead to erratic behavior or intermittent issues. Keeping the braking system clean and free from debris also assists in prolonging component life and maintaining functionality. Adhering to a strict maintenance schedule will ensure the electric brake booster and sensor perform optimally over time. In conclusion, addressing DTC C1C02-14 in the 2017 to 2022 Honda CRV is critical for maintaining both performance and safety. This diagnostic code highlights integral problems with the brake pedal stroke sensor signal circuit, necessitating immediate inspection and troubleshooting. A thorough review of wiring, connections, and component health should be conducted to ensure no detail is overlooked. The solutions outlined, from checking for shorts and opens to verifying the integrity of connections, are essential steps in diagnosing the root cause effectively. Timely interventions not only enhance the vehicle's reliability, but also significantly contribute to the overall safety of the occupants. Continuous commitment to preventive maintenance will serve to ensure that the brake system remains robust and functional, preventing future occurrences of similar issues. Please like and subscribe to the channel. See you next time.